All right, good Friday morning, everybody. This is Tim Armstrong at the National Weather Service in Wilmington, North Carolina, and I'm here to present a presentation on how we can use National Weather Service weather radar to help watch bird migration. Now, weather radar is one of our most powerful tools that we use for severe weather forecasting. It was never designed with watching birds in mind, but it's one of the great tricks that we found out that radar is capable of over the past 30 years that this network has been in existence. So we'll go ahead and get started here. This is the table of contents of what we'll discuss today. We'll start off with radar basics, looking at the National Weather Service radar network, and then we'll contrast that with special avian research radars that are specifically designed to watch birds and their migration. We'll then look at the spring and fall bird migration events, which actually the spring migration is beginning now. And I'll talk about birdcastinfo, an excellent web resource run by the Cornell Lab of Ornithology. And then we'll look at a couple special cases called roost rings and also birds trapped in the eyes of hurricanes. So some other interesting things that you can see on radar. So a little bit about the National Weather Service Doppler radars. We have one here in southeastern North Carolina in the town of Charlotte, that's in Brunswick County. And this is what a weather radar installation looks like. First of all, you've got this tall tower, 100 feet tall, and on top of that tower is what looks like a large white golf ball. And in reality, that's called a radome, which actually is made of plexiglass, and inside there is the radar equipment itself. That's a 28-foot wide dish that spins around on its axis, transmitting radar energy outwards and listening for echoes from anything that has water in it, mainly raindrops, snowflakes, and hailstones. But birds and insects and even bats have water in them as well, so they will show up on radar as well. You're most used to seeing radar imagery displayed like in the bottom right there. That's an image of Hurricane Florence striking the area in 2018. This is what radar imagery looks like that we see here at the National Weather Service and that also all of you can see on the internet or on your local TV stations. So here's a basic idea of how radar works. The radar itself will fire a microwave pulse. And when I say microwave, I literally mean just like your microwave oven at home. You may put your cold coffee in your microwave, heat it up for 60 seconds. That's 60 seconds of energy being applied to that water. When what we do here with our radars is we fire a very, very brief pulse of microwave energy. It literally lasts only 0.0000016 seconds. So we're talking about an almost infinitely small packet of energy traveling out from the radar. We then turn the radar off and it will listen for 0.001 seconds. That's still a very brief period of time, but that's 600 times longer than the radar was actually transmitting energy. That radar beam will travel out through the air, and it will be seeking out anything with water in it. When it strikes that, instead of heating it like your home microwave does, that microwave energy reflects back to the radar dish, which is listening for a return signal. By noting how long it takes for that microwave pulse to reflect back, we know how far away the raindrops or snowflakes or birds in this case may actually be. And by how much radar energy is reflected back, we know the size of the object, how many objects there are in the air. So radar technology was developed in World War II. We've expanded it and perfected upon it over the intervening years, and it's one of our greatest tools now in weather forecasting. This process I just described repeats hundreds of times per second, and the radar dish itself will actually steer itself around in a circle every 20 to 30 seconds, getting a complete view around the radar of what's going on with the weather. It then actually will turn its elevation up slightly, repeat the process again, and after a 3 to 6 minute process, it's completed what we call a volume scan, a complete three-dimensional picture of what the weather's doing over that radar site. These radars, on the next slide, are spaced about every 125 miles apart across the country. We have a network of 159 radars in the National Weather Service Doppler Radar Network. And using this network, we can get a complete picture of what the weather's doing across the entire United States. All this data is saved, it's archived, and it's freely available to anyone who wants to see what a storm was doing on a certain date 20 or 25 years ago even. All that data is freely available for you there. The National Weather Service operates one of the greatest radar networks in the entire world. We have complete coverage from coast to coast, plus Alaska, Puerto Rico, and the Hawaiian Islands. And when you composite data from all these radars together, you get an image that looks like this here. This was a big spring storm back in 2019 that stretched from the Texas Gulf Coast all the way up into the northern plains. This is the power of weather radar to really show a complete picture of what's going on in the weather across the United States. Now, turning it closer to home here, the radar that covers southeastern North Carolina and the PD and Grand Strand region of South Carolina, it's located in a town called Charlotte, that's in Brunswick County. And from that vantage point there, it's able to see the weather that occurs across most of southeastern North Carolina and northeastern South Carolina. Now, on this night here, April 27th, 2019, there was no weather going on, essentially. The skies were clear, the winds were calm. There really wasn't anything to look at, but our radar was picking up quite a bit of activity. Now, if you just looked at this radar picture alone, you might think there was light to moderate rainfall occurring across all the area. In reality, almost everything you're seeing on this radar scope here is actually birds. Late April is the heart of the spring bird migration season. And in this case here, we're looking at literally what is hundreds of thousands of birds moving northward from the tropics across the Carolinas to spread out across the great forests of eastern North America, including the United States and Canada. This is what we would typically see for several weeks during April into early May as the spring migration occurs. Now, there were some researchers at Clemson University in South Carolina about 20 years ago that, using various methods, did research to relate what we see on radar with actually how many birds are in the air. And from their research paper, they were able to determine these thresholds here. What they determined as light bird migration, that shows up as 5 to 10 dBz on the radar here, which if you look, 5 to 10 is the light blue colors on there. They were able to determine that represented 59 to 71 birds per cubic kilometer of airspace. Now, what's a cubic kilometer? Think of a 1,000 meter by 1,000 meter by 1,000 meter cube of airspace. So essentially a kilometer by a kilometer by a kilometer of airspace there. Within that area, you would have, from their research, 59 to 71 birds in that cubic kilometer, which would be light bird migration. Now, the greens that I'm seeing across portions of Columbus County there, they would term that as heavy bird migration, 20 to 30 dBz's on our radar. That represents upwards of multiple hundreds to even low thousands of birds migrating across this area. In this case here, that's how we were able to determine that there were likely hundreds of thousands of birds moving across eastern North and South Carolina during this bird migration event in April 2019. And their research is online if you do a search for their names there. Now, the National Weather Service radar wasn't really built with bird migration in mind, but there are some radars that researchers will operate during bird migration season to get an even more precise handle as to what is going on. These avian research radars look very different than our National Weather Service radars. Instead of a large dish, you see these flat panels, a vertical and horizontal flat panel display. These are actually what are called phased array radars. It's a very different technology where you have very, very exquisite detail, but the range is not quite as long as our National Weather Service radars. Now, using data from this, they're able to actually see individual birds during their migration. And this is what their displays look like here. This is from a 2012 study in around the Great Lakes. In May of that year, this one frame here shows individual birds, these streaks you see in blues and purples. These are actually individual birds moving through their study area. They're able to get precise counts of of how many birds there are, and even the altitudes that they're migrating at. On the right, you'll see a three-dimensional display actually showing what altitude the birds were migrating at. In this case here, most of the birds were at or below 3,000 feet above ground level. Now, by running this radar for several days during migration, they were able to do studies about when the birds are actually migrating. And you'll notice that during the daylight hours, say from 6 a.m. until about 7 p.m. in the evening, the bird numbers are very, very low. And that makes sense for a lot of reasons. If you're a small songbird trying to complete a multi-thousand-mile migration, you're really worried about getting eaten by a hawk, for example. So you're going to stay low in the trees and rest during the day. When the sun sets at night, though, there's a couple of factors that make migration easier for them. One is it's dark. The hawks are not going to be able to see you. A second factor is actually at night, when the winds here at the surface become light, you'll have what's called a low-level jet, a stronger streak of winds a couple thousand feet above ground level that develops. The birds can take advantage of this and actually use that wind as a tailwind to help them to move to their migration grounds faster and without expending as much energy. There's also some pretty intriguing research that suggests that birds may actually use constellations, the positions of the stars in the night sky, as a guide to help them know which direction to migrate in. And of course, you can only see constellations at night. So there's several different reasons why bird migration typically occurs at night as opposed to during the daylight hours there. And they were confirming that with their radar studies here in the Great Lakes. Now, looking at our local National Weather Service radar here in North Carolina, this was for a April 27, 2019 migration event. And you can see we're noticing the same factors that they saw on their Great Lakes study. Very little radar reflectivity during the day, but at night, right after sunset, the number of birds that we're inferring were migrating across us on radar expanded massively here. We went from almost nothing to, again, your what the researchers would term heavy migration here, with thousands of birds moving across every location per hour across southeastern North Carolina. Now, our tools here don't enable us to cut cross sections and see very fine details like those avian research radars. Our tools are mainly made to look at severe thunderstorms that are tens of thousands of feet tall. But if I chose the radar data from that bird migration night and look at it three-dimensionally, almost everything is down really close to the ground level there, certainly below 5,000 feet, most likely in the bottom couple thousand feet of the atmosphere. So we're again confirming that the research that they did in the Great Lakes also appears to be the case here. Now, fall migration, after the birds have moved into their breeding territories for the summer, they of course are having babies. Fall migration is an even bigger event than spring migration. You've got all those extra chicks that are now headed south. They're grown up to adults very quickly in the summer and early fall. They're headed south to the tropics. So the number of birds that we see during the fall migration in September and early October is much, much larger than we see during the spring migration. This is an example here from September of 2018, showing what our radar images look like. As the sun goes down just after 7 o'clock, the bird migration numbers go up tremendously. And again, you see here heavy to very heavy numbers of birds moving across southeastern North Carolina. You'll also notice that the echoes themselves, you can sort of get an idea, things are actually moving southwestward. They're following the coastline down from the east coast of the United States all the way down. Some of these birds will actually cross the open waters of the Gulf of Mexico on their way to Central America and South America, which is where they spend the winter. So very interesting that we see both spring and fall migration, but we notice much more bird activity in the fall because of the higher number of birds from the breeding season that just concluded. Now, there's a really great website that's run by Cornell University in New York, but it also has support from NASA and NOAA, that's the parent organization of the National Weather Service. It's called birdcastinfo, and I can't recommend this highly enough if you're interested in bird migration, figuring out what nights that heavy migration is going to occur and how you might be able to see some of this yourself. Type that into your web browser. They do daily forecasts. They actually use National Weather Service wind forecasts to help plot where the bird's going to move. They actually use live National Weather Service radar data to show you when birds are actually migrating at night, and you can look at that across the entire country. For example, this is one of their forecasts here during a spring migration event back in 2019, where they're plotting on the map here from low, medium, and high levels what birds are actually migrating in real time here. This is actually uses National Weather Service radar data, National Weather Service wind forecast data, and models of their bird activity to integrate in a live map where the birds are moving. In the fall, we see the same type of thing. The birds are now moving south back toward the tropics, and then the colors on here indicate a much larger area of medium to high bird density because there are so many more birds involved in the fall migration than in spring. Now, there's a couple other really interesting things we can see on Weather Service radar that don't involve the spring and fall migrations, but more local activity. The first of these is really interesting are what we call roost rings. And when Doppler radars were first introduced widespread back in the 90s, people started seeing these, and it took a few years for the research community to talk to the bird experts and sort of figure out what this was. But essentially, purple martins, one of the common birds we see across the eastern United States during the summertime, after their breeding season has concluded, they will form assemblages of thousands to sometimes tens or even hundreds of thousands of individuals. They do this for safety from predators. One bird can alert the rest of the flock. But at night, they'll form these great assemblages of birds on common roosting grounds. And when they take off in the morning at sunrise, searching for food, they'll spread out in a large concentric ring that expands outward. And our radars can actually see this here. Now this was back in late July of 2019. This is located very close to Lake Moultrie, South Carolina. Now there are volunteers who will go down and try to estimate the number of birds who are nesting at these sites or roosting at these sites. They were estimating that there were 400,000 birds at this single location here in the year 2013, and almost 500,000 birds in 2014. So we're talking about an extremely large number of birds involved in this communal roosting site here. Every morning when the sun rises, they'll expand outward looking for food, and we see this pattern repeat for several weeks during late July, sometimes into early August. This doesn't really persist much past early August, though. Purple martins are one of the first birds to arrive in the spring. They're also one of the first bird species to leave North America and head back to the tropics during the fall. So usually by the middle of August, we don't really see the roost rings occurring anymore. Now, we also have roost rings that occur here closer to home. This one was in downtown Wilmington, actually, in 2019. Looking at the precise location this ring expanded out from downtown Wilmington, it appears to be very close to the state port on the Cape Fear River, and likely was an area of reeds, that's a grassy area near the river that the birds were using for their nighttime communal roost. Their location they choose changes sometimes from year to year. For example, in 2021, we noticed that the roost rings were not coming from downtown Wilmington, they were coming from the northeast Cape Fear River near Castlehane. And in this case here, this appears to be a large area of river cane that was located just west of the Highway 421 bridge in Castlehane, where it crosses the northeast Cape Fear River. And this occurred for several weeks in late July and early August of 2021. Now, where will the birds end up this year? You have to ask the birds. We have no idea, but we assume they move to wherever has the best habitat for them in that particular year. So we'll start watching our radars very closely in July to see where these roost rings show up here in the Cape Fear area. Roost rings are not just a coastal thing. They occur at sites all across eastern North America. Here in the Carolinas, you can see several that usually will show up near man-made lakes or reservoirs or naturally occurring grassy areas near rivers. And there are multiple ones that will appear every morning during July and early August across the Carolinas. Now, one more really interesting special case where we see birds on radar, it has to do with eyes of hurricanes. Now, hurricanes, we hate to see those approach the Carolinas, but sometimes they do bring some interesting visitors from the tropics. Seafaring birds, that's birds that rarely come to land, maybe just to breed, but otherwise are always over the ocean, can get trapped within the eye of a developing hurricane. What actually happens is, as the birds are moving along and they're trapped within the expanding ring of very, very strong winds within the eye of or outside the eye of the storm, they're trapped there and they're forced to move along with the storm wherever the storm goes. That can be north over the open ocean toward the British Isles. That happens occasionally. But more interestingly for us, when a powerful hurricane hits the southeastern United States, once that eye dissipates, the stronger winds begin to weaken, the birds that have been trapped in there for days or sometimes up to a week are then free to try to find their way back to the tropics. In this case here, this has actually happened multiple times over the past 60 years. I've got a very interesting radar image here that was captured from the Morehead City radar. On the left image, that's just your typical radar reflectivity. That's the images that most of us are familiar with from the internet or from TV. On the right is a special type of radar image called differential reflectivity. What this actually does is the radar can measure not just the overall brightness or how reflective the raindrops, snowflakes, or birds are. It actually can measure their shape. And in this case here, we notice that the hurricane itself is made up of mainly greens on the differential reflectivity chart. That means that most of the raindrops or snowflakes or hailstones are mainly circular. They have the same measurement on the left to right axis as they do on an up and down axis. Whatever's in the eye of the storm here is showing up as white, which means that it's incredibly longer on the left to right axis than it is on the up and down axis. Think about the shape of a bird when it's flying. It's got its body parallel to the ground, so it measures much, much longer in that left-right dimension than it does on the up and down dimension. That's what the radar is showing us there, is that whatever is trapped in the eye of the storm here is not shaped at all like anything you would see in meteorology. It's not anything at all like a snowflake or a raindrop. It's much, much wider than it is tall. So that's one of the ways we can infer that in this case here, what was in the eye of that storm was not meteorological, it was most likely birds. And here's some interesting examples to try to confirm that here. We actually have on our weather buoys offshore cameras, little webcams that report back, not just, it shows images to go along with the winds and waves and temperatures these buoys report. In this case here, during the eye of Hurricane Dorian back in 2019, we saw multiple bird species flying around these buoys here. Now, I'm not exactly a bird identification expert, but I did show this to one of my buddies who is, and he thought that possibly it's one of the storm petrel species or possibly one of the rare oceanic terns that we don't see near shore very often. But whatever these were here, these were birds that were trapped in the eye of the storm, had likely been moving with Hurricane Dorian for quite some time, and were picked up by this weather buoy here. Now, here in the Carolinas, we have seen many times where landfalling hurricanes have moved birds far, far away from where they should be and deposited them here in the Carolinas. I won't read through all these here, but you can see if you are familiar with bird species, none of these are birds that we would typically see anywhere near North Carolina, the coast or inland. But in all these cases here, they were associated with landfalling significant hurricanes going back all the way into the 1950s. So if you are a bird nerd, and I would consider myself one of those, hurricanes certainly can give you an interesting eye on birds you wouldn't normally see coming into this area here. So that concludes my presentation, and I'd be very, very happy to take any questions. And my colleague Steve Paff is going to be helping to relay those questions to me, and we'll see if we can get some answers to you.
Yes, great, Tim. Thanks. This is Steve. If anyone has any questions, feel free to put them in the question box or the chat box that you have on your go-to webinar menu there. And in the meantime, while people are waiting, Tim, I was wondering if you can address, we talked about birds, non-meteorological targets, but what are ways other non-meteorological targets can help with respect to confirmation of tornadoes and maybe even where survey teams should go in response to severe weather that has occurred?
Well, that's right. Anything in the air that has water in it or on it is going to show up on the radar. So we normally think of radar as seeing raindrops, snowflakes, and hailstones. But for example, after a significant tornado, there's a lot of debris that's lofted up off the ground into the air that takes, sometimes 15 or 20 minutes to settle back down to the ground. The radar can actually see that, and using that differential reflectivity and some other techniques we have as well, we can identify that it's not raindrops we're looking at, it's debris with various shapes and sizes and not moving at all like the winds that is embedded within. In those cases, we actually call that a debris ball. It's a signature on radar that we are familiar with and know how to detect. That's confirmation usually that a pretty significant tornado has occurred, and it can give those survey crews a really good handle on exactly what areas to go survey, knowing that damage has likely occurred there.
Thanks, Tim. And we do have a comment here, question. Let's see here. Comment from Clem says, Tim, fascinating, thank you. Being both a bird nerd and weather nerd, you answered my question regarding non-local birds showing up after a storm. Thank you so much. Again,
and I mentioned that, oh, go ahead, Steve, I'm sorry.
No, go ahead, Tim.
I was going to mention that there's two sites that I found that had really good records about what birds have been noted here during hurricanes. One is the Carolina Bird Club, and you can just Google their website. They have reports that go all the way back into the 1950s that will actually tell you what rare birds have been seen in the Carolinas and how they got here. Another is another Cornell University site, ebird.org. It's sort of a citizen science portal where anyone, myself included, I've sent in a number of observations there, can report the birds you see in your backyard, or if you're at the beach, or anywhere really. And they keep a database of this, which helps researchers to determine over spans of time what birds are common in areas, what birds are uncommon, and they can link that up with meteorological records for hurricanes, for example, to see when birds have been moved by weather events like hurricanes.
Thanks, Tim. And just a reminder, any questions or comments, just enter them in and we'll get them to Tim. And, another thing, Tim, too, you talk about, part of our mission is weather and ecosystems. And, it's great when you have tools that can help other aspects of science, and, the cross-cutting and those linkages are so important. But also, how would radar help forestry in regards to maybe the intensity of wildfires that are out there, especially in rural areas where it's harder to assess potentially. What's your experience been with wildfires and radar?
Yes, we see the smoke plumes on radar pretty easily. Smoke is not just, there's a lot of water in smoke, essentially. You're burning wet wood when there's a wildfire, so there's a lot of water in that column, so it shows up very, very easily on weather radar. So it helps forestry experts to determine where fires are burning, what direction the smoke plumes are moving. In out west, where you may not have the high populations that we have here in the east, sometimes radar or satellite is the first indication there's been a wildfire. So it helps as like an early indication tool for the land managers, the forestry experts, to help them keep a handle on where fires are burning.
All right, Tim, we have another question. So there's some meteorologists with us participating today, and this one is from Mark. He wanted to acknowledge to the press that our radar has been receiving in regards to the beam blockage from trees in the area, particularly to our south of the radar. And in the fiscal year 22 appropriations, the National Weather Service has received funding to start the process to relocate our radar, which is set to begin in the fall of this year. So this is the first step in that will involve in finding a new location. It's exciting news, but there's still a long road ahead. But the question he has for you, Tim, is how do you think this might impact our ability to view birds and their migration after that move occurs?
Yeah, certainly a radar move, I think, will improve our radar coverage here in southeastern North Carolina and northeastern South Carolina. So it will improve our ability to not just see meteorological things, but non-meteorological things like bird migrations. It will certainly improve that.
Okay. We'll give it 10 more seconds. Anybody with additional questions, comments, feedback? This will be recorded. If anybody would like a PDF version of this presentation too, that will be made available. I can attach that to all the people who registered for the event. In addition, I will share the YouTube link of the recording once we post it. So I'm not seeing any other questions or comments. Oh, wait, here's one more question. Clem has a question for you, Tim. Does radar have any negative impacts on birds?
It does not. In fact, one of the really interesting things about how little energy our radar actually transmits, the average energy usage for our radar is actually no more than a home microwave oven. Your microwave oven transmits a continuous signal for that 60 seconds it's heating up your coffee or your tea. It's just a continuous beam of energy. The radar uses no more energy than that over the long term, but we just save it up and send out brief pulses. And the pulses are so brief, they have virtually no impact on living things. In fact, in speaking to some of our radar technicians who actually maintain the equipment, they talk about inside the radar dome itself. So right there, in the path of the transmitter, there are living insects, wasps and bees and so forth, that are not affected by it at all. So any idea that the radar has a negative impact on the environment is really not supported by science or even by just local observations. So it's a completely safe technology.
Okay, thanks for that, Tim. And then you did have a comment from Ann. This is fascinating information. Thank you for providing these presentations.
Sure. And while I've got everyone here, I mentioned a little bit about citizen science. I mentioned ebird.org is a great citizen science place where people just like myself who aren't professional ornithologists, bird watchers, can actually become a backyard bird watcher and submit your observations for other researchers to use. We have a meteorological version of that also called COCORAHS, COCORAHS.org. And that's where you can place a rain gauge in your backyard. And there's no training really with this at all. You don't have to be a professional meteorologist, but your observations that you send in from that rain gauge then become part of our permanent record here, where we can help to understand the climate and rainfall distributions better during storms. So citizen science opportunities in ornithology, in meteorology, even astronomy, I know there's some citizen science aspects to that, can really be a way to help participate in real science and help research move forward. So I can't say enough about all the citizen science volunteers who have done so much for the scientific community at large.
Yeah, that's a great point, Tim. And I think we should include those links in what we send to everybody. Very helpful. But a lot of comments coming in, thanking you for your efforts, Tim. I appreciate it. I know you're on shift doing other things too. So it's always great to hear from you. And special thanks too for our interpreters. Really appreciate their help today as well. So I don't see anything else. So I think we can close and end the webinar. So thanks again, everybody.